So, as I bore you, I would like to say that someone had only 5 slides last night and claimed everything that was remotely interesting in my section. Okay, so it's gonna go this way. My part. We're gonna do a small retrospective on what changed since we last met, since 2023, the last user group meeting, and since 4.0. I'm going to go over the more important things that changed. And we're going to see a bit what's next. Just a very, very brief overview. Okay. So since 4.0, so a lot of things happen. So some of the things that we've implemented. So this one was stemming from some ask from the user side, in particular Legion and a few tasking frameworks that wanted to be able from the same process to enqueue work on other GPUs. And so since 4.0 now we actually support this for all the device backends, for CUDA, for HIP and SQL. It's still considered experimental, but it's been around for a while, so it's at this time it's something that you can actually try. It's not going to blow on your face. It's just that there's some subtleties that so it doesn't. We don't have as much usage and experience as other things that you usually have, but it works. And the good news is we even went around and wrote documentation for it, so you can go find it. So the idea is when you do that, it's on you to manu. Yes. So the question was, how long is it going to be experimental? So the thing is, when you use it, you're not going to say experimental a single time. So I guess it's us warning you this is a bit newer, and when you use it, there is things you can do that could bite you. So for instance, okay, when you start doing that, so if we assume that you only have one GPU, right? Then when you make mistake on where you allocated your memory on what device and you access it from the host, we can tell you immediately. Like at compile time, we know it. We just don't know if you're going to execute your code. So we abort at runtime and we tell you exactly what you did. Now that we enable that, we open a really big can of worm, right? So you can do a lot of other mistakes, and the quality of error we will emit is not there yet. But it works, and you're not going to write experimental. So your code is not going to change when we say it's not experimental anymore, if that makes any sense. So say again? There probably will not be interface changes. No, there will be no interface changes. And so actually my next slide was kind of trying to illustrate what it might look like. So if you want to use it, so there's a little bit of heap code at the top where you yourself as a user, you explicitly have to create your streams, and then yourself, you set it to whatever device you want to do. You create your stream on that device. So we create a stream on device 0 and one on device 1. And then what you do is you create an execution space with Kokkos around both streams. And then you can pass them that's your token for execution, and you can pass it to all the Kokkos construct. You can launch here 2 parallel fors, and then when they get, when your execution spaces get destroyed, then we fence and whatnot. But you are responsible yourself to destroy your stream. So that's the idea. And as you see, there is no experiment. You don't spell out experimental, which means you won't have to change your code if you use it today. Okay, so that was one of the somewhat major things that we improved since 4.0, and you're welcome to go try it. If you don't need it, just, as I said, there's a lot of gotchas that come with it, so unless you really know what you're doing and you need it, I'm not suggesting that you need to do that. Okay. So then, since 4.0, another significant thing that we've done is, so you might remember from the 3.0 series, we had added this header Kokkos 2 algorithms, which was essentially us giving you standard-like algorithms, based on Kokkos that you can use in your code. That might sound more familiar if you use the standard library. And so what we did, so at the time there were things that you could call from the host, right? That was just one kernel launch. And so now we actually implemented versions that you can call from the team level. And so the signature should be pretty familiar. So you have the algorithm has the same form as the author one, except that the first argument, instead of passing an execution space, you're going to pass a team handle. So it's the same idea. You know, your first argument is saying where to execute, and obviously, just like what you've been used to, at the team level, you don't pass a label because we don't handle label from the team. But yeah, so these things are here, and yeah, you're welcome to go try them. For some usage, it's really a great deal of productivity, and the code is more expressive. Anyway, yes?
Quick question. How much for these team-level algorithms are you able to use vendor libraries like Kokkos versus enrolling your own algorithm?
For the team one?
Yeah.
For the team one, at the moment, we have not gone through the exercise of reusing a vendor library. For the external one, you know, the one that you launch from the host, there is a few that I wasn't gonna mention, but there is a few optimization where we did defer Mark to the first implementation, which is optimized and very, very good. So we haven't gone through this exercise for the team level yet. And there are also a number of very good internal improvements that we did on the algorithms that I'm not covering here, but they're getting better. So you should look at them. Okay, and here you've got a list of all of these algorithms. I am not going to go over them, but essentially we are trying to have all the ones that are available from the standard library that you can pick up and use with the Kokkos context. Okay, so another significant change, which is usually it's more the boring part, but it was a lot of work. So if you've seen my best practice tea time talk 2 months ago, I had a bit mentioned some of the major changes we had done throughout the last 7-8 years in Kokkos to the build system. One major piece of work was with 3.0. When we introduced proper, like CMake became our #1 thing that we distribute, and we had to do, tip of the hat to, in particular, Jeremiah had done a lot of the work, but it was enormous, the amount of work we had to do to move to CMake. And so in this series, we did from underneath you fit, it was mostly Daniel, but a lot of people work on that. Some significant change so that it's a bit more sane, the interaction with Trilinos. So essentially, all the work that should be transparent to you that we did was towards Trilinos treating when they build Kokkos the same way than anybody else Kokkos. Like we removed all the special paths they had because underneath the hood we are doing a lot of things to try to make sure that when you find Kokkos, it's essentially the same thing whether it was built with Kokkos, normal Kokkos, or with Trilinos, and that was a difficult thing. Anyway, so this is one major thing we did, and there's, in the next series there is also a lot of work we're doing, and that the build and packaging group is going to steward. That's going to improve your life. But yeah, I wanted to at least recognize that we did this. There's things that are very great because you don't necessarily see them, but improve your life. We One thing that's kind of neat that you might not be aware of, and we need to do better at documenting it, is you can actually, when you do development work and you actually change Kokkos, you could actually link against the build tree. Now it's actually pretty stable. You don't actually have to install Kokkos. So I'm not, if you just use a Kokkos as an external dependency, I'm not suggesting you do that. But if you're doing a lot of small change in Kokkos and you want to see how it propagates in your code, that's one option you could consider. If you want to know more, I'm going to volunteer some of the guys to write the documentation. Anyway, another thing that we did was, it was twofold. It was the people using Python bindings were running into all sorts of weird problems because they were messing with the visibility. And also some of our users were, even though we had never promised that we supported that, were passing visibility flags when they're compiling Kokkos, and it was creating all sorts of problems. But even though we didn't like it, we heard that it was a problem for users and we fixed it. And so another big one, another natural evolution is we are, as you may have seen, we are dropping support for makefiles. I understand they were really nice to work with, but we want to give you very strong guarantees, and it's very hard to support many ways of building Kokkos. So it was a long process. It was coming, but we deprecated it, and we're gonna remove it in 5.0. Okay, and then the last one was kind of hinting. It's coming more in 5.0. You're gonna have some improvement, but we understand that some of you guys don't really like the NVCC wrapper and other stuff that we do, a Kokkos-centric view of the world, and we are making a lot of work underneath the hood to reconciliate the two worlds, so that you can do either and match and compose with them. Anyway, this is a boring part, but just to let you know, we've really worked on this since 4.0. Okay, so another, yeah.
Is the in-tree way of using Kokkos going to stick around?
Yes. So the in-tree. So when you're in your code, you do add subdirectory. Yeah, it's gonna stay a first class. It's a very, if you saw my best practice talk, we recommend that. You can find in the documentation. We're gonna support that, and in fact that's how we deploy it in Trilinos. So you can be sure we care a lot about it. Okay, so this one, it's another of these really great changes that if we do it well, you're not gonna see anything. But I really want to stop and recognize that we've done that. So I joined the team just before, like, end of 2018. Okay, and we have internal priorities, which actually we're trying to work better to show you. And since I've been here, I mean, it's been a joke for a long time because it's always been one of the priority, one of the highest priorities is refactor. And since at the time we had the excuse that MD-span wasn't actually standardized, so it was difficult to say we're going to refactor everything because the implementation was fluctuating, trying to adjust with what we actually standardized. But C++ 23 has been out for a while now, and yeah, we've done it now. Like a lot of people have worked on it, and actually, Nick and Christian, like tip of the hat. I was really skeptical. I don't know how many times I told these guys that we're not gonna delay the release for your thing that's done in a week. Next week it's done, and often I actually blocked it a couple times because I didn't want to do it just before the release because it was risky. But this is deployed now in develop. It's going to be in 4.7, and we encourage you to try it now to see how it works. We understand there are a few subtleties at the moment. We still need to work out customization point on the Sakado side in Trilinos, but it comes with great things. So you've got plumbing that's much more sturdy than what we had in the past. There are some cases. Christian has run some compiling benchmark and whatnot. There is some really good things that come with it. We understand there might be a few difficulty in the short term, but overall your compile time are going to be better, and you're going to have things that can operate much better with standard C++, because you can now get out of your view, you can get an empty span. Anyway. This is one of those things that you don't usually see too much in the, in the change logs, because they are internal things, but it's major. Like we've been working on it for a long time. Okay, so I'm gonna skip that, and I'm gonna list a number of very significant improvements that we did since. Since 4.0, now SQL, the SQL backend is now it reached production level. So we started a while ago, and there might be some difficulty with the system with the systems, but our backend is there, and it's been reliable for a while now, and so it's in production, and so I wanted to highlight this. Some other notable improvement is were around the sorting. So some of you guys, we know that for some of you guys it's important, sorting, and we had sorting for a while, but it's still not as good as we wanted it to be. So we improved performance in many places. We added sort by key, which, just like sort, is available both from the host. You can use it at the team level, you can use it at the thread level. We have overload for all of these. It still doesn't have all the things we want, but it supports custom operator, just like comparator, just like you can do with the standard library. And we're getting there. So anyway, it's let us know what's really suboptimal for you guys, and maybe it can help prioritizing what we're gonna do. But we've significantly improved it. Another thing that's been a lot of work and still in flight is the SIMD library. So you might be aware of this, but in C++26, so it's not been voted in. No, it's in the draft. So C++26 is not officially out, but with 26 we're gonna get SIMD in the standard. And so we've been doing a lot of work aligning the Kokkos SIMD so that whatever you have now is gonna be essentially a pathway towards using just a standard facility whenever it's available to us. I mean, depending on how aggressive you are in your application at adopting new standards, for most of us it means at least 10 years. But what we're doing is making sure that whatever code we make you right now is going to be very aligned with future code. And if you want to know more about the subtlety of what we changed, you can look at our change log, or you have some of our specialists in the room. I'm definitely not the guy to explain exactly what we changed. So another one big improvement, actually, I would have probably even made it a new feature, was so you know how we have MD range policies that you can call from the CPU. It's really handy, right? Not having to do it by hand, even though we know that there's some things that are suboptimal, and we're going to improve them. But anyway, it's a really great deal of productivity when you can use that. And we had over the years many people telling us, wouldn't it be nice if we could do that from a team and not have to do it ourselves? And so we heard you. And so now we have, since 4.0, introduced team thread MD range, a team vector MD range, and a team thread vector MD range. And that's really improved productivity of the maintainability of the code you write. And so it's there, and if you didn't know, you should go and use it. Okay. So now it's a fun one, so really an improvement. So we've done, especially as we were, so it's a bit similar to the multi-GPU thing. So we've been, we know that a number of you guys, some of the coming from the tasking world, but not only them, were interested in being able to use Kokkos from different threads and potentially concurrently doing things. But there were a number of changes that we had to do to actually give you stronger guarantees, so that you don't do absolute garbage when you start doing that. We had seen paper where people would compare using Kokkos serial from threads and submit two execution instances, and then show that the result was really bad, which made sense because we only had one execution space and we were serializing everything. And so we decided to improve all these things so that we don't look so bad when people publish this paper, which are, it's not really something we recommend doing anyway. But so to be able to do that, we had to become thread safe, and that was an interesting journey. So we did all of this change through the 4.0 release series. But it came with interesting things. So people were using only serial and really didn't care about thread safety, had some non-trivial performance regression. So we had to introduce new flags that let them say, promise, I don't care about thread safety, I just want, So essentially the knob is called enable atomic bypass, because the most notable thing that you get is your atomics are not atomic. But it's great. It makes that your code would be portable if you re-enabled it. But anyway, so most of our backends now, so we went through all of them, are actually thread safe, and even though we're gonna on the side of caution, we're gonna say it's a bit experimental. No, we have very strong confidence now that it actually does the right thing. And so here is the kind of code you can do and it will work. So what this code is doing is you are starting two threads that concurrently will act on the same data from two threads, and you can do that with Kokkos now. This is we actually guarantee this is going to work. We actually test this kind of things. Solving what thread safety bugs was an interesting road. In 4.3, we had quite a bit of an incident. So a number of our users who either ignored our advice that was there, forever in our documentation, that was saying, you don't want to do a view of views, please don't do it. And then it was saying, okay, if you really want to do it, here is how you should do it. And we were really precise on how you do it the right way. And so apparently a lot of people thought they knew better. And so what happened when they upgraded is that their code started hanging, because now we were thread safe. And the very high level of what was happening is you would have, conceptually it was the same as if you were nesting two parallel regions. So we're thread safe now. You dispatch to the default queue or to one queue. So we acquire a lock, right, to make sure that things are in order, that you can have someone on another thread try to dispatch to the same queue, and that you don't do absolute garbage, that we actually submit in order the work. And so what was happening is within the region, you're trying to dispatch another parallel region. So you try to acquire the lock, and voila. It's going to take a long time before the lock is free again. So this very little, some people were actually doing that, but not that many. Most people were doing view of views. So it was essentially a similar problem that was happening. And we discovered late how widespread that usage was. And so we actually ended up introducing new semantics for it. So I guess how much time do I have? So I'm not gonna go into the details. We actually recorded the slides in the 4.3 and 4.4 release briefings. But essentially, we had to introduce some new semantics to requalify some of this use of view of views that was naughty, because we understood that that was not that easy to fix for some code base. Okay. So Christian has been talking about some. So here you've seen all the improvement and new features that we've done that was significant. But yeah, we always do a lot of maintenance and management of our technical debt underneath the hood. And here I wanted to highlight some work that the team has been doing in the goal. The goal was to really improve the quality and really hunt down vulnerabilities that we had in the code base. And so you might be, so we've been running all sort of static analysis and runtime analyzing. But one of the things we've been doing, which we thought would be interesting for you guys to see, because you might be running these tools also on your code bases, is we've been specifically trying to enable from ClankTidy the bug-prone checks, which amongst all the various sort of checks that you can run. If you're starting a new code base, by all means, you should enable everything if you can. But it's kind of risky to do it on an old code base and just go and try to fix things. Okay, fixing all over the place. And so we did it for the bug prone. And to give you an idea, for Kokkos, so it represents about 90 checks. So when we turned it on, we had 32 types of reports. So we had like hundreds, like a few thousand reports. And so we worked through most of them. And so a word of caution: if you do it on your own code base, you should come. If you have questions, you should come talk to us, because we have experience. So we really marched through all of them carefully, trying to resolve. And we actually found throughout all of these things, so a good number. So in yellow here, 16. Were things where, yeah, it was fine. It was, I wouldn't call it a false positive, but we could rewrite our code so that we express clearly that it was our intent and that it was fine. Sometimes we refactored the code and improved it significantly. Like it's more maintainable, clearer what we wanted to do. And sometimes we just suppressed it because it's just, we are naughty, we know it, but we express really clearly that's okay. But we found bugs. Right, and so I guess my word of warning, if you do it in large code bases, is don't just go try to shut up your compiler. Yeah, shut up your compiler. Do it carefully. You might introduce real vulnerability in your code if you do that. And so, anyway, I'm not going to go over the list of things that we changed, but that was some of the major things. Yeah, I'm going to do everything in 1 minute. Don't worry. So a lot of missed things that I'm not going to cover because I'm running out of time. That are other notable improvements since 4.0. So we're going to upload the slide. You can find them, but it's essentially things we covered in release briefing before. And I'm not going to cover this. One thing I want to cover. So it was just a release policy and our policies for support. But what I want to show you is how we've been doing since 2020. So all these dots are showing when we released. And you can see we greatly improved. We became much more regular on our frequency of releasing since 4.0. We were always saying, yeah, we do every 3-4 months, but we are really close to being at 4 months, and we actually plan in the 5.0 release, we're going to actually announce ahead of time our calendars. It's going to be a fixed schedule, and so we're going to keep this progression towards being predictable, so that you guys can compose much better, get ready for breaking changes and whatnot. Okay, I'm out of time because I didn't manage very well my time. If you If you have any question, specific question, you can find me afterwards. Let's see if Nick will allow 1 or 2 questions. No question. Great. Thank you, guys.